For this example, we're looking at finding the angles in a right angle triangle. So if we think back to what we've been doing up until this point now, we've been looking at using the trigonometry ratios, so whether that be sine, cos or tan, and we've always been given the angle in each question. The thing we've always had to find was one of the side lengths. So what do we do now when we're given the two side lengths, but what we're trying to find is the angle? So in this case, we're looking for this particular angle here, which we've used the symbol theta to represent the angle that we're trying to find. So what we do is we use the same principles, but this time we apply the inverse of any ratio to find the actual angle. So to break this down, for example, let's look at this example here. So we've been given the hypotenuse, which we know is opposite to the right angle, and that's 24. And then we look at our reference angle, which is right here, where I've put the question mark, which means that 16 is our adjacent. So given that we have the adjacent and the hypotenuse, and we're trying to find the angle, let's write down our acronym. So SO, CA, and TOA. And let's look at what we have. So what we do have is our adjacent and our hypotenuse. So if we look at the acronym, we can clearly see that both the adjacent and the hypotenuse exist if we use cos. So traditionally we write our formula or our equation as cos of an angle equals adjacent over hypotenuse. If we substitute our values in, cos of the angle equals 16 divided by 24. Now the problem that we face right now is that we can't just divide it by cos because we don't actually know what the angle is. So in this case, we do what we call the inverse. So for every ratio, if you take a look right up here, we have a corresponding inverse formula we can use. So for example, if we take the first one, cos of an angle theta is equal to adjacent over hypotenuse. So the inverse of that, we say, is the angle equals the inverse of cos, bracket, a over h, close bracket. So let's take that principle and apply it to this question. What I'm going to do is say theta equals the inverse of cos, divide that by 16 on 24, and if I put this into my calculator, what I'm going to get is theta equals 48.19. But remember, the question asks us to find the angle. So your answer is not complete until you say that it's 48.19 degrees.